I'm Pete.
I'm Stephanie.
Welcome to the Cool Parts Show.
This is a special episode of the show all about cool parts that we saw at RAPID+TCT 2022 in Detroit.
This is not a countdown, it's in no particular order, and it's just a sample. We saw tons of cool stuff at RAPID+TCT. Here's a sample of what we saw. Stephanie, you'll get us started right after this.
This episode of the Cool Part Show is brought to you by Carpenter Additive. The company's Powder Life solution is a combination of hardware and software technologies designed to help AM users manage their metal powders. Stay tuned after the episode for more on how the system works. Okay, our first part comes from Joule. This is a Japanese company that just recently launched an electron beam melting additive manufacturing machine into the market. But Joule has a long history of using electron beam technology. They make things like scanning electron microscopes, and now they are applying their knowledge of how to design and control electron beam systems to additive manufacturing. So the part we are looking at is actually a part of that electron beam melting 3D printer, which is itself 3D printed through electron beam melting. Specifically, this is the column for the Electron Gun. This is a component that would typically be machined, usually out of a material like carbon steel, and it needs to be very, very rigid. Any sort of vibration could mess with the performance of the Electron Gun. In this case, Joule chose to 3D print it. They used electron beam melting, of course, and they made it out of titanium. They were able to lightweight this component, so you can see this sort of like beautiful lattice they introduced to kind of showcase that. And this component was available faster because they were able to electron beam melt it. Joule was able to do the manufacturing in-house rather than outsource it to another manufacturer.
Here is a ceramic piston for a real automobile. This was developed by Panopolis Automotive in Greece for their Chaos Ultra car in development, like a sports car that's aimed for speeds above 300 miles per hour. A ceramic piston can take the heat. At RAPID+TCT, X-Jet had this on display. The piston was made using X-Jet's nanoparticle jetting system for 3D printing. X-Jet's process jets material using very, very fine particulate, which makes it possible of attaining geometrically very precise features, meaning there are components that become candidates for ceramic as the material where you wouldn't think of them as being ceramic applications. Now, ceramic engine components, the application, the importance of this potentially goes way beyond just going fast. Run a car engine at much higher temperatures and you can get more energy efficiency, get more power out of the same amount of fuel, potentially at higher temperatures get to an energy efficiency of an internal combustion engine that rivals the overall efficiency of an electric vehicle.
Our next part is actually a collection of parts made by Dimensional Innovations. This company uses large format additive manufacturing to produce architectural elements, artwork, and now furniture. This is a collaboration between Dimensional Innovations, Braskem, and Slice Lab Design Studio. So this was a test of one of Braskem's new materials. It is a carbon fiber reinforced polypropylene made from recycled bottle caps. Dimensional Innovations printed this table and chairs using their Thermwood LSAM, large-scale additive manufacturing machine. And something distinctive about this printer is that it has this roller behind the nozzle that sort of compresses and pushes down the material to make sure that there's good layer adhesion. That actually proved to be a challenge in this project. Dimensional Innovations was using a not standard nozzle. They were using one with a smaller bead size because they wanted to create these cool topographic features on this furniture. But that smaller bead size meant that the roller was compressing the material too much. It was causing kind of this oozing effect. And so they had to go through a lot of iteration to just kind of figure out the right printer parameters, the right speeds and feeds basically, to figure out how to work with this material and that new nozzle. So this is just a great illustration of how the material, the design, the printer, all have to work together for an application like this to work. And now they've got it figured out. They've got a way to print with this material to make products like this.
This little part is a component of a ball screw mechanism in an aircraft. 3DO California was showing this among various other metal 3D printed components. 3DO manufactures components additively using its own process and its own platform. It involves spraying metal powder along with a binding agent, machining forms as they're built in the green state, then sintering after that. This part is made of 17.4 pH stainless. It is a ball return tube, and one of the critical requirements is consistent roundness and diameter of the passage all the way through this curving form. So just taking a tube segment, and bending it into this form would not have been a candidate for this part. This part is notable because of what it represents. This is additive manufacturing arriving in full-scale industrial production. This ball return, 3DO is currently manufacturing this at the rate of 13,000 per year.
All right, we're going to go from aerospace back down to Earth. This is the KAV Portola bike helmet. It was on display in the Jabil booth. So this is a custom helmet. KAV can take measurements of a biker's head and produce a helmet that is custom made to their anatomy. This helmet also has some special features. It has sound dampening. It's about 25% lighter than a typical high-end bike helmet. But what's really cool here is that the filament, the material that was used to make this helmet, was created specifically for this application. So KAV came to Jabil, they were looking for a filament that they could extrude to get the customization in this product, but it also needed to meet or exceed the safety requirements. It needed to have a good quality surface finish, and so Jabil took up the challenge. They created a proprietary material just for this application. It is a carbon fiber reinforced polymer, and that development took them only about 6 months.
Desktop Metal now incorporates so many different additive manufacturing capabilities beyond desktop, beyond metal. Here's an application of 3D printing foam. Durachain resin from desktop metal company Adaptive 3D splits into 2 phases while curing. One phase can form a tough outer layer that contains and controls the expansion of the other phase. And Adaptive 3D is learning how to 3D print with tiny pores of air inside, pores that can expand along with the expansion of that second phase of the material. The effect is dramatic and also repeatable. A cushion printed this way could expand up to 5 times the size of the original 3D printed part, possibly more. The part that results, it feels like foam. It is foam, but without the wasted material that is characteristic of conventional foam manufacturing, which involves molding and cutting. Also, parts can be produced through 3D printing at a size much smaller than they'll ultimately be. A mattress, for example, could be 3D printed inside of a machine that has a build volume way smaller than a mattress, but it expands to its full size during curing.
This next part is a waveguide slot array antenna. So devices like this are usually made through machining or through assembly. You might have lots of little parts that you're brazing or soldering together. That means they're difficult to manufacture, they're limited in terms of geometry, and it's really difficult to make changes or to customize these things. So 3D printing this slot array antenna saved time and allowed for the features to be placed exactly where they were needed. But this part is a little bit of a fake out. It looks like copper, and it's not. This is a stereolithography print. It is plastic that has been coated with copper. So I saw this part in the Repliform booth. They are the company that did the coating, and they had to do it in sort of a couple of steps. First, there was an electroless nickel plating process that had to be applied to make the part conductive, and then they were able to electroplate it with copper. So this slot array antenna has a layer of copper on the outside that's about 50 microns thick. On the inside, it gets down to 5 microns in some places, but just that thin film of copper is enough to let this plastic print function as if it is a solid piece of metal for this application. So this is low cost, fast, lightweight polymer 3D printing being made more functional with the application of an additional coating. So lots of potential applications for waveguides, antennas like this, as well as parts in other industries.
Our final cool part from RAPID+TCT 2022 has something to say about the future of design engineering. EOS was showing this part. It's made from nickel alloy 718 on one of EOS's laser powder bed fusion systems. This is an Aerospike engine, and the geometric form was designed using an algorithmic modeling platform from Hyperganic. Aerospike Engine, a type of rocket engine that overcomes some of the performance losses that traditional rocket engines see at high altitudes. But it needs precise control over the direction of thrust, over the direction of fuel, over the combustion, and all kinds of strategic cooling all through the form of the engine to maintain operation within a tight temperature window. Hyperganic's design platform allows complex parts like this with complex requirements to be designed automatically once engineers have defined the algorithms, the equations that describe all of the various different needs of the performance of the part and also needs of the process. EOS is interested in this because the needs of the process can be defined within those engineering algorithms, within those equations from the very outset. Features, for example, that lend themselves very well to laser powder bed fusion. So having that definition from the outset assures from the beginning that the form the platform comes up with is going to be 3D printable.
There you have it, 8 cool parts from RAPID+TCT 2022. We have lots more event coverage as well. Check out episode 18 of our AM radio podcast for insights, observations, and trends that we saw at the show. We also have photos and videos that we filmed on site. We will drop links to all of that in the show description below.
Thanks for watching.
Thanks again to our sponsor, Carpenter Additive. In addition to supplying metal powders, the company also offers services, software, and hardware to help AM users manage their powder. One example is the Powder Life System, a combination of cloud-based tracking software with hardware designed to make powder handling easier. 2 key components are the Powder Life Hopper and the automated docking station. Luke Boyer, manager of Powder Life Applications, and Andrew Holliday, applications engineer, explained how the system works.
So today, when a user of additive manufacturing is receiving powder, they oftentimes receive it in either 5, 10, 15, maybe a 20 kilo bottle. But they're receiving pallets of them, and you're receiving 10, 20, 50, hundreds of these bottles. The user has to look and segregate and store them appropriately so the bottles don't get mixed up. And it requires a lot of lifting and moving and labor.
The components of Powder Life are all based around making powder management systems on the additive manufacturing shop floor easier to use for the operator, cleaner, as well as more traceable. 3 of those basic parts of Powder Life are our Powder Life hoppers, or our storage containers for powder. The second would be automated docking systems that allow material to be pushed in and out of machines with no human contact. And the third would be our Powder Life online software system that allows you to trace this powder as it goes through your shop floor.
The hardware, the software together just helps really streamline that and improve the final user's experience and let them concentrate on going from design to the part itself. Takes the headache of powder management out of the equation for them.